Namaskar. Dear viewers, today we'll be discussing the topic climate science. You know, climate change is the greatest challenge of 21st century. Looking at the gravity of the issue, United Nations and other organizations under United Nations have brought out a lot of programs to strengthen climate literacy, to make aware about the impacts of climate change, make possible every individual, every citizen to take a proactive steps to address the issue of climate change. In this regard, today's session will be discussing about the basics of climate science. The end goal is to achieve climate literacy. We very well know that the issue of climate change, how important it is, because it is affecting every one of us in every activities. The last century, if you see, the average surface air temperature has increased to 1 degree centigrade, and it is reported by Intergovernmental Panel on Climate Change that by the turn of 2030 or before 2050, the average surface air temperature may cross 1.5 degrees centigrade. Indeed, it is a great concern. 1.5 degrees centigrade increase in surface air temperature means think about the cryosphere, think about the glaciers in the polar regions, Himalayas, think about the organisms. Multiple organisms will be threatened, and we are already in the era of sixth mass extinction. So, the impacts are pervasive, and it doesn't have any borders. Every one of us will be influenced by the issue of climate change. The second important aspect is that we all aspire to have a sustainable lifestyle. We aspire to have progress in every way, either it's economic development or environmental development, sustainability. But this development process, the trajectory will be affected by climate change. We need to invest a lot of money in the adaptation measures or mitigation measures. So in that way, it is going to challenge the economy of every country. So all the more important is we should be literate, climate literate. So today's agenda, if you look at it through this presentation, we'll be discussing about the issue of climate change through the mechanisms, through the processes that is involved in the climate system. Second, we'll be talking about the basic, difference between climate change and climate variability. Third important thing is that we'll be talking about the causes of climate change, whether it is natural causes or human-made causes. To start with, we need to understand the meaning of climate and climate change. When you talk about climate, it is, basically a state of the atmosphere with respect to the parameters, meteorological parameters like temperature, the pressure, normal meteorological variables. So this state of atmosphere of that particular parameter for an extended period of time, it will be more than 35 years. That is the meaning of climate. When you talk about climate change, it means that the state of atmosphere of definitely the parameters, meteorological parameters has to be taken into account for an extended period of time, and what exactly the changes in terms of the mean and variability of the meteorological parameter. So this is climate change. So having said the meaning of climate change, it is for a longer period of time. It takes a lot of time for the system to acclimatize, climate system to acclimatize, and also there are many factors involved in the changing climatic conditions. So we'll be discussing one by one the factors. Having talked about climate change, we need to understand the basic components of climate system. When you talk about climate system, it means that it is a totality of the components of climate system like atmosphere, hydrosphere, cryosphere, biosphere, and also its interaction. So it's the most important aspect is not only individual components are important, the interactions, that is very important. So we'll be discussing each and every component. The first important component of climate system is the atmosphere. When you talk about atmosphere, we know it is very chaotic, it is not stable, and this, when I say it is not stable, it is chaotic, it means that the composition of atmosphere has to be taken into account. When I say composition, atmosphere is made of certain gases. When you take dry atmospheric air, it is made of nitrogen, oxygen, and trace gases. These trace gases, though the quantity by volume, if you see, it is less than 1%, but it is very significant as far as climate dynamics is concerned. Because these trace gases, like your carbon dioxide, nitrous oxide, methane, it is in minuscule quantity in the atmosphere, but its effect is phenomenal. Why it is phenomenal? We'll see. These gases are called as greenhouse gases. Okay, they have the ability to absorb the long wave radiation, and thereby they can heat up the atmosphere. And this effect is called as greenhouse effect. In fact, these gases are responsible for causing climate change and global warming. These gases, we have to see what are the reasons why it is, the concentration is increasing year after year. It is increasing. We have to find out the reasons, figure out the reasons, then we can go for certain strategies, mitigation strategies. Okay, this is about atmosphere. Second important component is hydrosphere. When I talk about hydrosphere, it includes the water body on the land and below the land as well. When I talk about on the land, it can be the river flow, the lake body, pond ecosystems, and the most significant is the ocean, because 70% of Earth's surface is covered by ocean. So it is definitely going to have a greatest impact on the climate system. And also the hydrosphere, it also includes the subterranean water, groundwater. That also plays a significant role as far as the climate dynamics is concerned. When you talk about the hydrosphere as a component, how it is going to influence, how it is going to interact with the other components of climate system, let us take an example of ocean body. As I said earlier, it is 70% of Earth's surface is made of ocean. And this ocean, it's a huge water mass. This huge water mass is having a lot of benefits, a lot of benefits. The first and foremost benefit as far as climate science is concerned, it can store a lot of heat energy. It's a very significant aspect, whatever the energy we are getting from the sun, it has been trapped and stored in the ocean body for a longer period of time. If definitely because of this reason only, the fluctuations, temperature fluctuation is minimum. Otherwise, it would have been more. Okay. The second important point as far as the ocean body is concerned, the ability of the ocean to sequestrate carbon from the atmosphere. The carbon sequestrated from the atmosphere is converted, transformed into certain salts, carbonates and bicarbonates. In fact, these carbonates and bicarbonates are very important for the sea organisms, living beings in the ocean body. But these carbonates and bicarbonates have a significant role to play in the climate dynamics. Just because of the carbonates and bicarbonates, the concentration of carbon dioxide in the atmosphere is less. Otherwise, it would have been more. Okay. So when you look at the evolution of Earth, the carbon dioxide concentration in the atmosphere was multiple times. It's more, almost 2000 ppm, more than that. But what happened? Because of the continuous precipitation, the carbon dioxide present in the atmosphere was washed, and it was captured by the ocean body, and it has been converted to carbonates and bicarbonates. And that is the reason why the carbon dioxide concentration has reduced. Otherwise, our Earth atmosphere would have been very warm. It will be very difficult for the living organisms to thrive. If you look at the average surface air temperature global Earth, it is 15 degrees centigrade. That is the reason why our life is possible. We are existing. Water it will be in the usable form. Otherwise, living organisms cannot survive. So, this ocean body plays a very important role as far as climate system interaction is concerned. Third important aspect as far as the ocean is concerned, there is a circulation called thermohaline circulation. It is influenced by the seawater content, seawater and temperature. This is called as thermohaline circulation. This is much slower than the atmospheric circulation. Okay. Atmospheric circulation is definitely, as far as the pace is concerned, is much faster, but this thermohaline circulation is slower. Nevertheless, it's playing a very important role. Why? Because if you see the Earth, the main source of, when we look at the Earth's surface, the main source of energy is from the sun. Whatever the energy we are getting it from the sun, because of the orbit of Earth, if you look at it in the equatorial region, more of radiation is received, and that is the reason why it will be heat surplus. In the polar region, it will be heat deficit. So whatever the energy it is gained in the equatorial region, it has to be transferred, or it has to be moved towards the deficit region. It's a basic concept. So how it is done? So for this to happen, that's why the Earth will be stable. Otherwise, it will not be. So the atmosphere will be stable. So how it is done? There is two ways. One is the atmospheric circulation, Hadley cell, Ferrel cell, polar cell. These, atmospheric circulation helps to move the heat, whatever gained in the equatorial region, to the polar region. Okay, and this is with regard to the atmospheric circulation. But as far as the ocean body is concerned, it is called as thermohaline circulation. So this thermohaline circulation is playing a very important role as far as the heat budget is concerned. Okay. Next point is, it is having, since it is a water body, it is having the inertia, thermal inertia. So that again is very important as far as the keeping the temperature at that optimum level so that living organisms can survive. So these four important roles is played by the ocean body. This is about the hydrosphere. So here I've discussed with you the role of atmosphere and hydrosphere. What is the interaction? Each and every component we have discussed, and also how it is interacted. Now let us go to the biosphere. When I talk about biosphere, we are talking about the living organisms. Let us take vegetation. Vegetation, it is, it's playing a very important role to change the dynamics, or in other words, it will influence the carbon cycle, because vegetation, through the process of photosynthesis, it takes up the carbon from the atmosphere. So carbon is sequestered, because through the process of photosynthesis, the carbon in the atmosphere is reduced, or it has been fixed in the plants, crop plants, or any plants, vegetation for that matter. So this carbon fixation is a very, very important exercise in the carbon cycle. Otherwise, the carbon dioxide concentration in the atmosphere will be much higher. Okay, so this vegetation is definitely, when you look at the equatorial region, the kind of diversity, the kind of vegetation we are having it, whether it's Amazon rainforest, or in the Australian region, say all along equatorial region, it is rich in vegetation because of the favorable temperature, the moisture availability, and the climatic condition as well. So this vegetation, in fact, for example, they say that Amazon forests are lungs of the earth, because it is taking up the carbon dioxide from the atmosphere. It is making the environment livable. Okay, Amazon rainforest. So the vegetation is playing a very, very important role. And the same, when you talk about the living organisms, whether it is the algae or other biota, even on the ocean body, there are many photosynthetic organisms are there. They are playing a very important role to sequester the carbon from the atmosphere. Okay. Second aspect, as far as the biosphere is concerned, is the soil. When you talk about soil, it's a substratum. It is a substratum for the growth of the plants, definitely is providing a lot of nutrients to the growth of the plants, and it also plays a very important role in carbon cycling. Because whatever the carbon sequestered through the photosynthetic process or the biomass, it will reach the soil and it will be fixed in the soil as soil organic carbon. The role of soil organic carbon is very, very important, because the soil organic carbon will have a very important role to play as for the life of the organism in the soil environment. When I say life of the soil in the soil environment, I'm talking about the soil organisms. There are many organisms are there. These soil organisms will be playing a very important role in the agro-ecosystem, cycling of nutrients, even energy. So these organisms are very important thing. So this soil organic carbon content in the soil also will have an important role to play as far as climate dynamics is concerned. For instance, if whatever the carbon stored in the soil ecosystem, if it is released into the atmosphere, what will happen? So the carbon dioxide concentration in the atmosphere will be increasing. So now, how best we need to take certain steps to make the soil organic carbon fixed in the soil system. So for a longer period of time, the carbon should not leave the soil system. Okay, so that way also this soil will be interacting with other components of the climate system. Okay, and also if you see the soil, the land surface, the texture of the land surface also will be playing a very important role as far as the wind circulation or atmospheric circulation is concerned. Okay, this is about the biosphere. Now, another component is cryosphere. Cryosphere is basically when you talk about cryosphere, it's another component of climate system playing a very important role. The first and foremost important role is the albedo, reflectivity. When I talk about reflectivity, 30% of the energy that we are receiving from the sun, it is reflected back into the atmosphere. It's a very important role, albedo. It's called as reflectivity. This cryosphere, basically it includes the glaciers in the polar region, Antarctic, or even in the Himalayas, wherever you're finding the ice mass. That particular region is very important as far as the reflectivity is concerned. The second important role as far as the cryosphere is concerned, it is also involved in deep water circulation also. Okay, and the third significant aspect is that in certain parts of the world, particularly in the northern hemisphere, most of the regions are being covered by frost, permafrost, permanent frost. So what happened? Just below the permafrost region, many particularly living organisms, the biomass, they have been present deep layers, and through the process of decomposition, it would have been converted into methane, because anaerobic environment is persisting there for a longer period of time. So the carbon in the biomass would have been converted to methane. This methane is covered by the permafrost region. So now, if the temperature is increasing, it's galloping. If it is galloping, what will happen? The glaciers will melt, the permafrost will melt, and the methane lying in the deep layers will be released into the atmosphere. So that will be having a forward loop. Forward means it will have a positive climate feedback. Okay, it will increase the temperature of the earth still further. So that is a very significant component or significant aspect of cryosphere. Next aspect is, we had just discussed about the different components of climate system and how in each and every system is interacting. For example, as I said, that melting of glaciers, what will happen? In due course of time, if the glaciers are melting year after year, decades after decade, the methane lying in the under the permafrost region may be released into the atmosphere. That may further the temperature rise. That may increase the temperature further. And also, this melting of glaciers will increase what? Sea level. So, increase in the sea level will definitely have a role to play as far as the thermohaline circulation is concerned, number one. Second point is that the glacier melting will also play a very important role in the salinity of the ocean body. And that means that thermohaline circulation will be influenced. Okay. And very important aspect is that this ocean body is also vulnerable in nature because how much it can hold the carbonates and bicarbonates. If the carbon dioxide concentration is increasing, so definitely certain phenomena like ocean acidification also can take place. So how cryosphere is interacting with the hydrosphere, I've just explained to you. And now atmosphere is also having an important role. Carbon in the atmosphere, how that will be trapped by the ocean body in the form of carbonates and bicarbonates, how much it can hold. So what the physical and biological properties or the chemical properties of ocean, what is its capacity? How much it can hold the carbon. So this all interaction has to be taken into account in totality. This is called climate system. Going further, we need to understand the causes of climate change. We discussed about the climate system. What is climate? Climate change, climate system. So the most significant aspect in this case, when we talk about the causes of climate change, we need to understand one aspect, that the major source of energy on Earth's surface is sun. So whatever the energy we are getting from the sun, 30%, as I said, it is reflected back. 20% of the solar radiation has been captured, absorbed by the gases present in the atmosphere, shortwave radiation. 50% of the shortwave radiation has been absorbed by the Earth's surface. So this 50% of shortwave radiation, that is SWR, it will be reflected back to the atmosphere. And when it is reflected back, certain gases present in the atmosphere, which I called as greenhouse gases or radiatively active gases, these gases will absorb the long wave radiation and it will be reflected back towards the Earth's surface, causing warming of the atmosphere from the bottom to top. This is called as greenhouse effect. So now the major source of energy the Earth is receiving is from the sun. So when we talk about the natural causes of climate change, it will be related with the solar energy, solar output. Okay. When you talk about the solar variability, though the quantity, the percentage will be less, nevertheless, it is having a huge impact to play as far as the the climate change is concerned. Because when you look at the evolution, when you look at the age of the Earth, it's almost 4.5 billion years ago, the man came into existence perhaps 10,000 years back, and his actions, economic actions and economic activities caused climate change or industrial activity, whatever you call use of fossil fuels. It is almost 250 years back, 1750. Since 1750, industrial activity started. So, but in the past, in the geological past, the role of solar radiation, the solar output is very, very important. Okay, so this solar variability is prime cause for natural climate change. Whatever happened in the geological past, it is because of certain natural phenomenon. So in that case, this solar variability is the prime factor. The second is orbital variation. We know the Earth revolves around the Sun. These orbital variations also have an impact on the climate of Earth's surface. The eccentricity, the Earth's revolution around the Sun, the path, it can be, that's called as eccentricity. It can be a circular path or elliptical path. This, whether it is the variation, the oscillation between the circular path and the elliptical path is almost 1 lakh years. So this is a very significant aspect. This is called as eccentricity. And when you talk about another thing is that the tilt angle. When you talk about tilt angle, the present day, if you see, the Earth's axis has been tilted to 21.5 degree. Okay, and it will be varying from 21.5 to 24.5. So this is called as precision. The other one is the wobbling. So these kind of orbital variations also, whether it is a precision, or eccentricity, precision, or wobbling, these all can have an impact on the climate system. These oscillations is popularly called as Milankovitch oscillations. Okay, and it is very important as far as the the changing climatic conditions, the major, tangible thing you can find is the ice ages. In the past, whatever the ice ages that has occurred in the geological past is because of orbital variations. Okay, that's called as Milankovitch oscillations. The third important thing is tectonic processes. When you talk about tectonic processes, it means that the movement of lithospheric plates on the Earth's surface. This movement of lithospheric plates are very important because just because of movement of these lithospheric plates only, there is formation of fold mountains, Himalayas, Andes, Rockies. There are many mountain formations. Even the formations under the what you call that ocean trenches. There are many things. So these are all called as tectonic plates. So now these movement of lithospheric plates also can have an influence on the climate. For instance, the formation of Himalayan ranges, the Tibetan plateau, it's a highland in fact, the Tibetan plateau, this formation of Himalayan mountains and Tibetan plateau also is responsible for desert conditions in the Central Asian countries and also western part of China. So the tectonic plates also is very, very important, okay, as far as the natural climate change is concerned. Next is volcanic eruption. See, volcanic eruption, because of the volcanic eruption, there may be a lot of gases, some aerosol particles will be released into the atmosphere. These aerosol particles, because they can scatter the light, whatever the radiations back to the outer atmosphere. Because of that thing, cooling effect can be, it will be happening because of the volcanic particles. Okay, so these are the four important processes responsible for natural causes. Now, let us go for the anthropogenic drivers. When you talk about anthropogenic drivers, very significant aspect that we need to take into account as far as anthropogenic drivers are concerned is that, human beings' action are responsible for causing climate change. Okay, this action or activities, it has been more phenomenal or more prominent after Industrial Revolution. So when Industrial Revolution started, we started using more of fossil fuels. We started using more of coal, oil, and so on and so forth. So by this way, we started emitting more of carbon dioxide into the atmosphere. So our actions started, human beings are responsible for causing climate change since the Industrial Revolution. Okay. Because of our action, the prominent aspect is the increase in the greenhouse gas concentration in the atmosphere. Greenhouse gas concentration in the atmosphere has been increased, definitely because whatever the fossil fuels we are using, it definitely it will add up to the carbon dioxide concentration, methane concentration, or nitrous oxide concentration in the atmosphere. These are the three important greenhouse gases in the atmosphere. The second important cause human beings are involved is land use changes. When I talk about land use changes, see, because of the increase in the population, there is a lot of demand on the land. Okay, we wanted urbanized environment, industrialization activity. We wanted to feed the growing population. So for that, definitely what will happen? The main process was deforestation. Because of deforestation, the carbon sequestration potential of the vegetation reduced. And that led to a very important aspect called, because a lot of pumping of carbon dioxide into the atmosphere, and definitely that has caused climate change. So the second cause is land use changes, deforestation followed by agricultural activity or industrial activity or urbanization. Okay, this is as far as the man-made causes are concerned. So to sum it up, today in the topic climate science, we have discussed about the basic components of climate system, how each and every component interact with each other, resulting in a lot of feedbacks, climate feedbacks. Second important aspect we have discussed is the natural causes. In the natural causes, we have discussed the prominent one is the solar output, orbital variations. Third is the volcanic eruption and tectonic processes. And lastly, we have discussed about the anthropogenic induced causes. When I talk about anthropogenic induced climate change, there are the most prominent causes: land use changes and and definitely use of fossil fuels and or any other economic activity that would have resulted in pumping of more of greenhouse gases. Thank you very much.